later in the day. It's not really a tutorial because we're all together, but I think I'll work on the practical problems. So maybe we'll go through that then in the tutorial, okay? No, the first hour will be something new, and then the second hour will be the practical problems then. Yep. And then we have the extra class then. Okay. So what we'll do is we'll start this next chapter. So I think I said quite soon actually you can start the coursework. We're starting a new chapter called exponentials and logs, or powers and logs. 1, 2. We have no class on Friday, isn't that right? Yeah, 1, 2. And we have a double class on Tuesday morning, no class on Monday. Oh yeah, so on Tuesday next week, I can give you your coursework 1 then. So you can start it, if you like, before the break and during the break then. Okay? So you will have enough maths to do the coursework on Tuesday next week. So I'll give you the coursework to do. I recommend that you spend some time. Looking at the coursework when I give it to you on Tuesday, so that you can ask me questions before the break then. Okay? You can send me an email, of course, and I will not reply, but you can still send me an email. That's not a problem. Okay. In fact, you can send me more than one email. Yeah. You ask, can you send an email? Of course you can. Now, will I reply? No, I will not. Yeah, but you knew this. Yeah. But you will send. I look forward to reading it after the holiday. Yeah. Okay, so new chapter, indices and logarithms. Yeah, now indices is another word for exponential. So there's actually 3 words we can use here. Shh, listen please.
A new word.
Yeah, indices, or another word for this is exponential. And another word for that, the one I will really use the most, and maybe is what you use, is powers. Okay, and logs just stays as simple logs. So we are going to look at this one first, the powers. Okay? So what I'll do is I'll run through the rules that we have. So some of the rules you already know, some of the rules we've actually used, but we're going to look at all the rules now. Can I scroll down? Yep. Is that yes? Okay, just give you a few seconds. I don't have any. Right. Scrolling down. So, the first rule of powers, and I'll do the proofs as well. The proofs are quite simple. X power n multiplied by x power m, and this is one you should know, is n plus m, like this. Yeah? Got that one? Yep. So, we'll do the proof, and the proof is quite simple if you think about it. Here we have how many x's? In this one, there's n of them, isn't there? And here, how many x's? M of them. So in total, we have n plus m of them. So that's x power n plus m. I mean, it's not even really a proof. It's just something that is obvious from what you mean by power n and power m. So this is n of them, and this is m of them, and together n plus m. So it's hardly a proof. xn multiply xm. Yeah, and these are all multiplied. So there's n of them here and m of them here, multiplied together. Yeah, is that okay? Now the next one is when we divide. And again, this is one I think you all know. So xn over xm, and what happens here with the powers? It's a minus, isn't it? Yeah. And again, the proof is hardly a proof. On the top, we have n of them, and on the bottom, we have m of them. And what happens is we can cancel. And each time we cancel, we have one less. And then when we cancel again, we have two less, etc. So we're left with n minus m on the top because we can cancel m times. So we can cancel m times. So we're left with this. Okay. Right, so write this one down. This is the second rule. So I should put these in boxes, or you should as well. So this is the first rule, most important rule. And then this is the second rule. And of course, x can't be 0 because we can't divide by 0. So, of course, for this one, x can't be 0. Okay, so that's the second rule. Let's have a look at the next one. Can I scroll down now? So, rule 3. When we have a double power like this, what happens on the top? Times, yeah. So this is x n m. And again, we'll have a look at the proof. So, how many of these do I have? I have m of them. Because what's happening here is this to the power of m. So this gets repeated m times. And by using the first rule, this is xn plus n plus dot 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 plus n. And how many of these are there? There's m of them. So we've seen this already. When you add the same number to itself, it's the same as multiplying mn. So that's the end of that proof. You remember this? Like if I do 2 plus 2 plus 2 plus 2, that's the same as 4 times 2. So it's the same idea here. There's m of these, so it's m times n. Okay, so that's rule number 3. If you can write that down, we'll have a look at rule number 4.
We could also say n.
Yeah. Okay. Can I scroll down a little bit? Fourth rule. Okay, so for the fourth rule, what will I do? Will I do the minus one next or the root one? I'll do the minus one next. The order's not important. I don't know. Well, no, I usually do the power one next. So if we have x power 1 over n. Yeah, this is the nth root of x. So power a half would be square root. Let's look at the proof. Yeah. So I'm saying x power 1 over n is the same as the nth root of x. If that's true, then if I put power n on both sides, it should still be true. Now, by definition, if this is the nth root and I have power n, what am I left with here? X, yeah, because if I had square root and I square, nothing happens. Cube root and I cube, nothing happens. So this is x. If I use rule number 3 here, the power is 1 over n times n from the previous rule. But what is this power here? 1. Yeah, so this is clearly true as well. So this comes from rule 3. So I'll just write here, use 3. And in the last one, what did I use? I used, this was 1. Yeah, use 1. And here I used 3. Okay. I used rule number 3. Rule 3. Okay, now rule 5. Rule 5, we'll do the minus power. So if I have x power minus n, that's equal to 1 over xn, yeah. like this. Yeah. And again, the proof, I suppose. Let's see. Yeah, I want to keep it easy enough. It's hard, well, barely a proof. I could prove it this way. I could say x minus n. It's hardly a proof. Yeah, that's x minus 1 power n. And here, which rule am I using? Rule number 3, isn't it? Yeah. And then this here, x power minus 1, that's 1 over x power n, which is 1 power n over x power n, which is 1 over xn. I mean, that's one way to prove it. Another way to prove it, x power minus n, that's the same as x power 0 minus n, which is the same as x power 0 over x power n. Which rule did I use here? That was rule 2. And which one was this one? Rule 3. Does anyone know x power 0? I haven't said that one yet. 1 over xn. I mean, there's a couple of ways to prove it. So I actually should say what the story is with 0. So 0 power n, what does that equal? 0. And then, let's say x power 0, 1. And what about 0 power 0? Undefined, yeah. Because if you look, you might say, oh, I can use the first one here, and that means it's 0. Or you might say, oh, I can use the second one here because it's power 0, and that would mean it's 1. And in fact, it's not defined. So I'll just write NA here, not defined. And lastly, 1 power n is always 1. Yeah? Is that okay?
Not defined like at all? Like
Yeah, undefined, no value.
How could that even be possible?
Yeah, well, it's a bit like, there's a group of numbers which have no value. So 0 power 0 is one of them. Does anyone know the other ones? Numbers that are like this, that are not defined.
1 over 0? No, that's not.
Yeah, 1 over 0, yeah. 0 power 0. Infinity over infinity. No, not this one. This is defined. Infinity power 0. 0 power infinity, yeah. No. It is defined, yeah. Yes. 1, 2, or 3 over 0, yeah. Anything else?
What about negative 1?
Yeah. Infinity minus infinity is not defined. I mean, you think it might be 0, but it's not. And lastly, which is relevant for today, which might be a surprise, 1 power infinity. Now you might think that this is 1, because it's just 1 multiplied by itself infinity times, but this is not defined as well.
1 multiplied by itself?
Infinite times is not 1. And you think it should be 1, but it's not. It's a bit like this one here. You think it should be 0, but it's not, okay? And in fact, a little bit later in the week, or maybe next week, we'll see an example of why this is not defined. Yeah, this one. Yeah.
Should we write these down?
No, you don't need to. I'm just saying these are examples of numbers which are not defined. Yeah. And I think the one that's interesting for today is this one.
How come?
We'll see later why it's not. It seems like it should be, but it's not.
Sometimes 1 times 1 times.
Yeah, it seems like it should be defined, but it's not. Okay. Do you have these 6 rules is what's most important, okay? So what we'll have a look at today, simple enough examples, is how to use these rules. So we'll do some very simple examples, but I'm sure they'll be too simple. Can I scroll down? Yeah. Okay. So we'll say something like, as an example, I'll give you 3 to do, and you can do them very quickly. B power 4, B power 8, Y 7, Y power 5, A power 0, and we'll do this one as well, X6 over X4. So this should only take you like 10 seconds to do. If you can do these now, please. Okay, so the first one, B power 12. The second one, Y power 35. This one here is 1, and this one here is X2. Yeah. Which rule was this? I'll just write them beside. This is rule 1. This one, rule 3. This one, rule 6, and this one here. No. 2. Yeah. But I think a lot of students would be able to do this before seeing those rules. You might remember them from school.
This is like the easy part of high school.
Yes. Yes. Okay. Can I go on to more difficult examples then? Yeah. Okay. Listen. Okay. More difficult examples. Right, so the next example I'm going to do, it's using these rules to simplify something complicated. So we'll say something like this: 4 root 16 all over 32, 5th root of 32, and this is all in a square root. So write this down, please. Write it down carefully. Okay, did you write this down? Yeah.
Can we guess what we're going to do next? Like 5 seconds.
No.
Oh.
No. You got. Listen. So I'll say this once, and then I'll say it again for the people who weren't listening the first time, and I might even say it a third time as well. So you can do this in many different ways. So to be clear, there are many ways in which you can do this. And if you're thinking, teacher, I can do this a different way, is that okay? The answer is yes, because there are many ways you can do this, alright? So I'm going to do this one way, and at the end, if you think of another way to do it, that is okay, alright? So, when I look at this, for me, the first thing I can see to simplify this is this 4 over 32. Because these can both be divided by 4, which is what I'm going to do first. So this will be square root 1 over, 8, isn't it? And this is square root 16, and this is the 5th root of 32. Now, when I look at this, to me, the next thing I feel like would be helpful is this root 16 is easy to get. It's 4. So that's what I'll do next. This will be root 1 here, this will be an 8, this will be a 4, and this will be a 5 root 32. Okay, so what looks like the easiest thing to deal with next? No, I think something before that.
32.
Yeah, the 4 here and the 8 I can simplify. The 4 goes into 4 once, and the 4 goes into 8 twice then. So now I'm left with root 1 times 1 on the top, and then 2 5th root of 32. Okay, so you know what, so you can have everything on one screen, I'll just go up here. this will be square root 1 over 2 fifth root of 32. Okay, so now what do we do next? No. In the exam, they'll want to see all the steps for this. Yeah, you could do the 32. Could be 2 power 2, 4, 8, 2 power 5. Yeah. So that would be, you could now use the, what rule is it? The fourth rule is what I said? Where this is 2 power 5, and the fifth root is what power? A fifth. Then what happens to the powers here? They multiply. So you're left with that multiplied by that is 1. So it's 1 over 2 times 2, which is square root 1 over 4, which is 1 over square root 1 over square root 4, 1 over 2. And they may ask you to write the answer as a power at the end. So this would be 2 power minus 1 then. In the exam, they'll want to see some steps. Now, they may not need to see every step to get the full marks, but it's just much safer to write down all the steps. Okay. This might be a 3 or 4 mark question, so not every single step is going to be necessary. Like, for example, I would say in the exam, it probably would be okay to skip maybe this step because, if you wrote 2 power 5 and you have the fifth root, then clearly that's a 2, so you might be able to skip over this step, But just to be safe, write down all the steps. Okay, so write this example down. Yeah.
Isn't that another way you can
in fact there is. Yeah. There's, in fact, many ways to do this one. Yeah. If you can think of another way, I welcome you to do it that way. The only way that's not acceptable in the exam is the calculator, okay? So if you just hit this in on your calculator and get the answer, you won't get any marks for that. Not even 1 mark.
Even that or what?
Yeah.
I think the calculator is good just to check if you got the right answer.
Yeah, you should use the calculator to check that you got the same answer, but that's all it's good for here. Yeah, when people type this in on the calculator, they gave the answer as 1 over 2, or did it give it as 0.5? Yeah. Now, do you all know how to type this fifth root in on the calculator? There's a button on the calculator that looks like this. Can you all find it? Let's see.
I don't think I have.
Yeah. It gave it as 1 over 2. Okay. What? Come on.
30. Roll is different, yeah. Let's try.
It depends on the question. You see, the question may have said, for example, give your answer in the form 2 power n. It depends on the way they asked it. Do you have this yet, Adnan? No, sorry, you're not Adnan, sorry. I realised that after I said it. Hesham, do you have this yet? Do you have it? Okay. Yeah. Right, can I scroll down? Yeah. I'm going to give you one that's like this to try, okay? So if you can try to simplify this one. Square root x fifth root x minus 5 all over x minus power minus 5 fifth root x5.
Why?
Why? Now, it's not as difficult as it looks, because here I'm asking for the fifth root, and here I have power 5. So it's easier than it looks, okay? So try this for a minute. That's okay, I forgive you. Try it for a minute. It's okay, it's okay.
Teacher, is there another way?
Yeah. Right, try this for a minute. And it's worth noting that, of course, for this one you can't use your calculator.
Well, if we find the value of x and just replace
Yeah,
it,
but the answer won't have x in it. It'll have a number answer.
Ah,
Yeah, so you can't use a calculator.
even with a number?
But the answer won't be what they're looking for.
No, I meant just to check.
To check, yes. But that's all. Okay, let's have a look at this one now. Listen. Yep. So, you're all going to have done it slightly differently, but what I see here, I could put these together, and then I could put these together. I think that's what I'll do. So, what I'll do here is I'll write this as root. Here will be x power 1, and this one is x power minus 5. Now, I'll say this just to be clear. If you have something like root a over b, that's the same as root a over root b. So, because these are both the same, I can put them together as 1. So this will be fifth root x minus 5 over x5. Now, here I can minus, so be careful, this is x power 1 minus 5, and then in the next one this is x power minus 5 minus 5. So this will be root x power 6, fifth root x power minus 10. Now, this will be square root x6, and this will be x minus 10 power a fifth. Yeah, which is square root x6, and this will be x minus 2. When they multiply, the powers add, so that's x6 minus 2, which is square root x4, which is x4 power which is x squared. Okay. Did you get x squared? The last step. You made it all the way to the end, and then the last step. Okay. Bad luck. What? You trust people too much. You trust me, you trust him, you trust people too much.
Yeah? In our country, people are more trustworthy.
Yeah, well, but they're wrong. So.
Experience tells us.
Okay, did you write this one down? No? Okay. Did you write this down? Let's have a look. So, huh? Oh, I see. You use the root and the 5 and you cancel them. Yeah. Yes, that's fine. Yeah, okay. Let's go to the next one now.
Imagine the homework.
Okay, come on, next one. So let's say something like this one. The question asks you to write this. I want you to write it in this form. A, x power a, and then a b with another power, and then a c with another power. Okay, so this is the way I want you to write it. What I'll do first is I'll expand the top. I can just use Pascal's triangle. We've done many of these. So the top will be 1 plus 3x plus 3x squared plus x cubed, and the bottom will be x squared. Now guys, come on, focus. Now, what I do next is each of these can be divided by x squared. So this will be 1 over x squared, and actually I should say, I should have, there could be an extra one as well. Yeah. So here I have 1 over x squared, and then the next one is 3x over x squared, and the next one is 3x squared over x squared, and then the last one is x cubed over x squared. So the first one as a, and that's like power 1 here. So what will be the first one as a power? It'll be x power minus 2. And then the next one would be 3x power minus 1. And then the next one would be 3x power 0. And then the last one would be x be 1. And this is like a 1 here, and this is like a 1 here. So you've written this in this form here. Yeah, so it's like, this would be A, and this is A, this one's B, this one's B, that one's C, that one's C, that one's D, and that one's like the D there. Okay, write this one down, please. I've seen this in the exam. Yeah. No, in maths it's case sensitive, so when I write big A and small a, they could be completely different things. Yeah. Okay. Have we got this one?
No.
Not yet? Yeah, it's because the question says explicitly write it in this form. So you're showing clearly what the powers and the coefficients are. Okay. Have you got this? Yeah. Okay, so there's 2 things left to do. They're both important topics in maths. It's a very important type of power. Can I scroll down a little bit here? Yeah. So there's one type of problem in maths when we have powers like this. Numbers like 2.71828 roughly, power, let's say 5. These types of problems are actually really important because this number here in maths is actually a really important number. And the importance we will see later when we start doing different topics. It's the E constant, yeah. This number here is roughly equal to E. And it's one of the 2 important constants in maths, the other important constant being pi. Now this one is important in trigonometry and geometry and problems like this.
That's not pi. Yeah, it's 3.
Oh, so what the heck? I'm not thinking, sorry. 3.1415926 something. Huh? What's what? What is this? No. You know what this is. Pi, or in Arabic, P. Yeah. Isn't it?
What's P in Arabic? There's no P in Arabic.
Are you still pronouncing it pi? It's still pi? Alright, okay, sorry.
P in Arabic, that's so funny.
Sorry. I just thought because when the students, I talked to them about Pythagoras, and they're like, who's Pythagoras? I said, Pythagoras. Like, oh, of course, yeah. Alright, anyway, you know this one because it comes up when you're dealing with the circle. Yeah. But where does this one come up? Does anyone know where we see this one? This constant? Which chapter in maths? It comes up when we deal with, mostly with calculus, which is this one here. That's something that we'll see later. Yeah.
We'll take a calculus in the first semester.
And second, sure. Differentiation, yeah. Anyways, just for today, we're not worried about these types of problems. We just want to know how to calculate this on the calculator. This actually is built in on the calculator because it's so common and important. If you look at your calculator, on the log button up the top, you can see there's an E power button.
Got it.
So I want you to type in E power 5, just to check, okay? Do you have your calculator?
Yes,
148.4. No, 148.41.
Okay. How about these? Yeah, roughly. Did you get this?
No, I can't hear you.
Do you? Did you find it, Turkey?
Yeah.
You found it? Yeah.
I made it the same. This one.
Got the same, yeah?
I didn't go to the setting. Just put the
Oh, you typed this, yeah, but the E is on the calculator. Yeah. Same answer, yeah. Guys, listen. So, as Mali was saying, if you type this in, you get the same answer as this. It's the same thing, okay? So what we want to have a look at now... Say again? Yeah, well that's later. Okay. Guys, did you all find it on the calculator? Yeah. Right, so what we want to have a look at next is the graph that it makes. Y equals e power x. So you could put in some values and you get different values for y. So for example, if you put in e power 0, well, you already know what you get here. What do you get? You'll get 1. And if you put in e power 1, what will you get? You should know this already. E power 1 should be about 2.7. So the graph that it makes, it will look like this. Now, some important features about this graph. So, out to the left here, the graph will be rather flat. In between about -1 and +1, it'll be roughly a sort of linear shape. But then after 1, it grows rapidly. Okay, so this is quite a fast growth here. And in fact, this is where we get the word in English exponential. So if I said something was growing exponentially, it means it's growing quickly. It has this quick, very steep, quick growth to it. Okay. We will look at what happens when we slightly change this. So for example, if we have y equals a, e, bx, and if the a and b are positive or negative numbers, like for example, if I have y equals 2e 3x, will the shape of this change? In fact, it doesn't really change. It still has this exponential growth. It only really changes when we start putting in like maybe a -2 or a -3. So I want to do the 4 different possibilities. That's what I want to finish on. Can I scroll down? Yeah. So we'll look at the 4 different possibilities. I'll put them in 4 boxes here. The first one is if A is positive and B is positive. The second one I'll do is if A is positive and B is negative. This one here, if A is negative and B is positive. And the last graph is if A is negative and B is negative. And remember, this is the graph of y equals A, E, B, X. Okay, so let me just put these in here. Okay. So these graphs are all for y equals A, E, B, X. So the first one, when both A and B are positive, the graph, let me put it in black, it looks like this, like we said a moment ago. Does anybody know what happens when I make the B negative? Yeah, it will be exponentially decreasing, like this. If the A is negative and the B is positive, the graph will look like this. And then lastly, if the A is negative and the B is negative, the graph will look like this. Please note also about these graphs is that they have no roots. So this graph never crosses the x-axis. And it crosses the y-axis once. And then what is this point it crosses the axis at each time? Yeah, but what is the value of it each time? Not in these ones? No, look here. If I put x is 0, what do I get here? A. A times e power 0, which is a times 1. So this always crosses the y-axis here at A. If the B is positive, the graph is increasing, or moving away from the axis, and if the B is negative, it's moving towards the axis. If the A is positive, it's up the top, and if the A is negative, it's down the bottom. So these are the last, they could ask you to draw one of the four. So they might say something like draw y equals 2e power minus 3x. So that would be, which one? 1, 2, 3 or 4? This is 1, 2, 3 or 4. This one would look like graph 2. And what would be this point here? This would be 2, the A, for example. Yeah. So this is usually a question in section A for like 2 marks. They just want a quick sketch. Okay, the homework A and B.
Doesn't finish the words off in there.
Don't worry, you still have tonight. A and B. Yep, okay. I have everybody here, don't I? Yeah.